So the next thing for this lab is to figure out the amount of mass to overcome the friction. And you see that we have 5 grams of mass attached to the system, and it is slowly rotating with no acceleration. So 5 grams is basically enough to just overcome the friction with no extra acceleration provided. So you cannot account for friction anymore. You ignore it because you add 5 more grams to your total mass that accelerates the system. So it gradually moves down with no significant acceleration. So your mass to overcome the friction is 5 grams. 5 grams is a decent result. And then we have to measure the distance traveled by the accelerating mass, and we will start from the top of the table, right here, and the height of the table let's measure it with meter stick. You can see that the height is 78 centimeters. So it goes all the way to the floor. And the distance traveled, the height mass hanger falls is 78 centimeters. So that's the initial setup. We overcame friction. We got the distance for kinematics part, and we got some data for geometry of the disk. It's the same disk. And now it's time to move on to rotation part and see how rotational kinematics is connected to translational motion of the hanging mass towards the floor. So I'm going to add some more mass, measure the distance. Well, we already measured the distance, so all we have to do is just measure the time that it takes for the disk to rotate enough, and accelerating mass travels downward. So on to the last part of the experiment.